that it was interesting. Now, if at any point you realize that this is all a total illusion, and you're welcome to go along next door to the next one, which is interesting. But there's some kind of Python-y stuff in here. I'm going to try and whip you through what I did, and then we'll see how much along the way I get to explain what I did the Python-y bits in. But I'm very open to interruptions, objections, picketing, mass protests. Yes?
First question. James Tauber recently released a thing about musical exploration without it being tied directly to the tone setting it's in and everything else. Have you looked at that?
No. I don't care about what anybody else thinks. But I like people who do interesting, creative things. I just don't have enough time to read. The internet is too full of boring things that I read to be able to read about such lovely things. Okay, so how this came about. This is the introduction because it's a musical talk, so you need an introduction. But we're not sure whether there'll be a finale or whether it'll all fall like a damp squid. So children learn music sometimes. I like music. I like computers. I like maths. And I did art at high school until I dropped out because I got a lower mark for art than for Afrikaans, which was my previous bottom grade, so I had to do something about it. And the only thing that I did successfully at art was understanding basic color theory, because I could write like a mathematical essay about that. The paintings I did, I don't know what, they weren't that great. And then my daughter got one of these little toy piano things that you can blow into, and it had different colors on the different notes, and then you can get these books and it shows you the color of the note to press. And the colors were arbitrarily assigned. An absolute outrage. I could not bear it. I was like, how are you going to help the child learn unless there's some kind of like visual I have a project. And as I said, I did use Python to do all this. So just an introduction. So how many people here have some vague kind of musical background? Excellent. You see, we should all actually be musicians because it pays far better. Then, and how many have some kind of vague mathematical background? Excellent. We should also all be mathematicians. Hooray. Now, 12-tone scales. So you see, you can be a rock star musician and make lots of money, although the majority of them don't, but you don't really get that many rock star mathematicians. Okay, so Pythagoras did this clever thing where he realized that you could divide pieces of string that were vibrating along harmonic intervals, and he thought that this was the key to understanding the lost secrets of the universe, which it may be. And so musical scales are based on this kind of harmonic intervals and things. And so in the old days, in the Middle Ages, in Western music, you had all these different scales which were based on people who got different ratios and applied them to strings or to things that they were blowing into or things that they were banging. And so that gives you different tones that are somewhat related to each other, right? But there was a problem with it in terms of like, it wasn't a very easy system to work with because you end up with all these complicated different rational ratios, but they don't all quite line up with each other. And then around the time of Bach, who has heard of Bach? He, along with Gödel and Escher, is one of those main computer programmers who didn't have computers and so had to do something else. So they invented this thing called the even-tempered scale, which meant that it was a scale that didn't have like moments of fury and moments of calm. It had pretty much the same character the whole time. And what that was, okay, so this is a little graph of it drawn in Matplotlib. You can divide a note in 2 and you get an octave. You can divide it in 3 and then you get what's called a fifth in music. These numbers are like confusing, but we'll just try and work with them, and if at any point it doesn't make sense, just pretend that it all does. And then you can divide it, so you divide it in subsequent, basically, divisions by primes give you this like distribution of these harmonies. So what you're seeing there is a logarithmic scale, log base 2, which is an octave. So if you're like, da, da, I should have brought my guitar. Then that's an octave, and that sounds like roughly the same note, just higher up, which is just dividing the frequency, or doubling the frequency. If you do fifths, then you get a different thing. So what this is a log base 2 representation of the frequency. So between one note and the note an octave up, this is where you get fifths. So from the bass note, let's say that's middle C, if you go up a third, so this is complicated, but you have to divide it by 2 because otherwise you actually get to note an octave and a fifth up. Then you get this thing here, which is 3 over 2 in log 2, which you can all calculate in your heads, right? Okay, so, and then what you can do is you can cycle that. So you've got a third, this third thing, you bring it down by half, then you go up again, and you can generate a whole sequence of frequencies, okay? And this is how you generated scales in the old days before they came along with this good old even tempered thing. So this is a plot of like gradually fading as you repeat doing this, the numbers that you get if you cycle around that powers of 3, then take them, divide them by 2. Is this making any sense? This should have been a maths conference. You guys, computer science is basically just a little branch of mathematics, and this is just slightly outside your normal comfort area. But it's a pretty graph, okay? And you can do the same thing up here. And what they realized was, look, if you just take 2 to the power of 1 over 12 and repeat that 12 times, then you get these 12 evenly spaced notes in the log space, right? And they actually map really nicely onto these other notes they were trying to get. So it sounds like the other things, but they fit properly together. What did I do? OK, I don't think this was connected to anything. Good. So that's where we start. And then Pythagoras had this other thing, which was the circle of fifths. So he realized this like thing, you can make a fifth tone, and then if you repeat that cycle, you get the sequence of notes. So like it goes actually da 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 da, and then you can start the sound of music. So that's important, otherwise you wouldn't have culture. So these are the 12 notes that get produced in that thing that we saw on the previous slide, arranged sequentially if you go just do 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 do, or arranged in this kind of circle of fifths way where they actually relate more to each other. And I'm just putting it up because it's going to be relevant to what we do just now. Questions? No? Good. So what I want to do now is I want to have the colors on the thing correspond roughly to something musical instead of being an arbitrary invention by a children's toy designer that has no use to the future musical and mathematical development of my child. Right. So what we want is we want a function on the frequency space that tells us how different are 2 different notes. Do they sound similar or different? Okay? That's a mathematical description of it. And we also then want to assign colors that have got roughly that difference between each other so that you can tell, like, oh, those notes look similar. They probably sound nice together. That's the general idea. That's what that says, right? Good. I'm going to try whip through this quickly, I think, and then we'll look at Python code instead. OK, so you can use the circle of fifths to do this because the numbers on the, not numbers, what are they? Notes on the circle of fifths are roughly in an order that somewhat relates to point to this, which is you can use matplotlib to draw pictures. So this is like if you arrange the notes in order and go up 1 semitone at a time, that's what they look like. But if you do it on the circle of fifths, then you get a nice, pretty spirograph type thing. Isn't it beautiful? Very important. You have to use Python to do this. It's impossible to draw it by hand. And then you get these really cool geometric structures, because if you go up 2 semitones at a time instead, then because there's 12 notes, and 12 is not a prime number, except on Saturdays, you get sequences, because it's divisible by 2, right? So look, you can draw pretty pictures. It was making me very happy. This is nothing useful in it. But what I did is I wrote these little, so I wanted to explore this space. So like, how do you as a computer programmer explore some kind of strange mathematical or musical or whatever structure? What you do is you write a little program, right? So what I had was little files which I write, which like generate these little graphs for me. But then as I'm exploring, I went on and changed the files, and then I had a little make file that makes all these pictures for you. It didn't put them into a presentation, which is why this is so ugly, because I did them just now. But it had it in a nice HTML page. OK, good. And then if you use the other, like if you go in cycles of 3, then you get different pictures, cycles of 4. Brilliant. So there's all this geometry for us to explore, which will help us to work out the relations between the spaces. Everybody's following now, right? Yeah. Excellent. OK, so how relatively discordant are different intervals? Well, in Western music, it's roughly like this. So if a note is the same as another note, then it sounds OK with it. Okay? If a note is 5 semitones apart, then that's the closest thing, then that's the sequence, roughly. But if you use the circle of fifths, you get a different sequence. So I was like, how do we handle the circle of fifths things? Well, matplotlib can draw 3D graphs, so we have to do something 3-dimensional. OK, so this is a donut, okay, which you might eat in the interval. So what I did is basically like, we need to have some cycling in that other thing so that we get away from the straight circle shape. So we'll distribute the notes around a circle, but then we'll take the circle and we'll put other circles around it and then go wee, wee, woo. OK? So, and that is, as you know, Python is executable pseudocode. So all I did was I said to my computer, go wee, 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 and look, out came this.
Is that screwing around the torus?
Yeah.
Okay.
So it does 3 cycles around the torus, and then it gives us the intervals that we want. Okay, so let's forget about all that. That's math. Now, colors. Who's interested in colors? Colors are a very important issue in South Africa. It's something we have to pay attention to. Okay, so here we have a color space. Now, you guys are more familiar with this stuff because you actually have to use these when you try and select the colors for your website or for your presentation, or not, as the case may be. So we've got RGB is the thing that we usually end up declaring colors in, which is a cubic color space. It looks like a cube. If you plot it out, it's got 3 dimensions, and it's from 0 to 1 or 0 to whatever in all those dimensions, right? But this space that I've got, so I'm going to try and map my musical space, which happens to be a like little curve around a torus, as everybody always thinks about it, to this some kind of color space. And there are these colors in the world, but it's not really like a cube, so that's not that great. So what about HSV? Okay, so who knows HSV here? Okay, so HSV is another way of defining colors where you define the hue, which is basically like where on the rainbow is this color, and then how saturated it is, like does it look really bright, or is it more like just a generally whitey color? That's not the right description, but ignore me. So if you have no saturation, then it's basically white. As you get to a richer and richer color, then it gets to the outside of the circle. And then the value thing is, like, is it really just a muddy brown, or does it have some kind of colorful definition to it? So as it gets more mixed with other frequencies. So the reality is that what happens in our eyes has got nothing to do with this. Or it is arbitrarily related to this, because light actually has many frequencies. And if you're going to explore this, it's like fantastically complicated. But HSV looks a little bit more like I want, because it's cylindrical, and because you can kind of go around the circle, and then maybe I could try and do some of that. So I thought this looks like a useful thing. But then I discovered there's also other spaces which are useful. So there's one called lab. So there are these people who study these things, and they invent color spaces. And they're weird. The color spaces they invent. I didn't say anything about the people. So the reason for this is that the way our eyes perceive color is actually complicated. So when you look at colors, you can see this combination of different frequency things, and your eyes give you different responses to that, right? So, and we think, oh, well, it's red, green, blue, but it's actually slightly more complicated because our eyes perceive the differences between the different receptors rather than just the measured levels on those different receptors. And there's actually colors and frequency combinations that most monitors can't give you, because they're producing like on these 3 particular frequency things, whereas actually that can't give you exactly all the things in the space. So people study all of this stuff, and they produce models like this. Now, the intention of this model is to make you think of a strange underwater vehicle. It also has something to do with colors. And so basically, at different points along here, you'll get different colors. So the thing is that like the brightness and stuff is not exactly independent from the colors. So you can't take like yellow and have a very dark yellow that's almost black, because it actually doesn't look like yellow anymore, right? And blues tend to look darker than yellows, and so they kind of made it more like how colors actually work in the real world, but far more difficult to compute about. Okay, so let's try and map this. So I thought HSV is cool. Let's just go around the rainbow, give colors from the rainbow to everybody. And so there are my notes arranged in the kind of ones that are close to each other on the circle of fifths, arranged around the rainbow, and then that's what happens if you actually play them next to each other on a piano, where you can see the contrast between notes that are close together, but the ones that are further apart actually look more similar like they sound. Is this making sense? Okay, and that's them on the torus, just because we have to do a 3D graph about everything. Okay, now the problem here is, can you see, does it look like there's a nice spread on that top left graph? So like, is it reasonably spread around the rainbow? Right, yeah. No, there's too much green. Down with the greens. So this has now become a political movement against the rescuing of the environment. Okay, so actually, there's only like red, orange, yellow, and then 3 greens, 4 blues, and purple, and then some vague pinky thing. What is that? So actually, the distances that we measure on that hue thing are not related to how our eyes perceive distance. They're just a nice way to spread things between red, green, and blue. So that sucks. So using the lab space, we can do something. So like, now this is to demonstrate you can also plot other funny curves in 3D space in Matplotlib. So like, I basically took around that hue space, and then there's this thing called delta E. So there are Python libraries that do this sort of thing. There's one called grapefruit, and there's one called color math. and all sorts of things. And so they'll do measurements. So people invented this thing called delta E, which is on the lab color space and is meant to tell you the distance between two things. And so then my little Python program goes and goes a little bit further along, repeatedly along the thing, until it tries to space out around this Hues circle, things that measure as approximately equidistant intervals. So has anybody ever thought how to separate out equidistant colors along the rainbow before? It's really hard. So this gets you a bit of a better thing. And there we go. Does that look any better? Yeah. So the reason I've never published this before until there was a need for a speaker is that I'm still not satisfied with that. It's not quite right. And so what you actually need to do is understand that the way that we perceive color depends not just on the color, but the immediate and background context of the colors. So there is another color space called JAB, which is cool, lab and JAB. But this set of color spaces, basically you have to define a foreground color and a background color, and then relative to those colors, you get a color space on which you can measure color differences that are actually more similar to the human eye. So I'll work on it, and I'll get there, but I couldn't find a Python module that did JAB, so that's what I plan to do next. So anyway, so we get that. Now, anyone recognize this?
Oh, this is not the tune, you mean?
Yeah, well, it's sheet music. I thought you might be able to get that far. There was a little hint on the slide. And the tune is Amazing Grace, which is usually played on bagpipes, which are the most colorful instruments there are. So I thought this is a good one to illustrate with. So I'm now going to put colors on all the notes. And then, ta-da! So the idea is that should give you some idea of the relative changes in the sounds as you play through the thing. And then the next thing to do is all you do is make your instrument so it's got little stickers on it. Now, actually, what I really did was, because I don't know who remembers there was this funny donut thing. Went woo, woo, woo. So there's actually two dimensions there. There's how far you're around it, and then there's the angle. So I put little angles on the things, which is meant to try and convey the same thing. But then, because I haven't worked on this since April when I was trying to prepare it, I realized that half my slides were broken. And so here you can see those little things, and then you can actually write the music with those little things on it. And then there's this correspondence between what you're seeing on the music and a note that you can press, or a fret that you can put your finger on your instrument. Does this make any sense? Yeah. OK, how am I doing for time? Good. So now, let's just look at what that looks like on a bigger piece of music. OK, so good old Robert Schumann. He wrote nice music. And what you can see as you go through the music is that it gradually changes key, but it's all relatively harmonious and beautiful because he was a romantic.
Did you generate this?
So, OK, so I used LilyPond to generate this. The reason I didn't mention that is because it isn't written entirely in Python, which is a grave offense. It's written in Scheme and all kinds of funny things, but you...
So you imported the mid,
so I did...
your own rendering form.
Yeah, so I did all the exploration of the colors using my little Python things, which I'll show you now. And then for this, I took those colors that I generated, put them into a little file, and modified the sheet music scripting thing so that it puts the colors and little dashes and things onto the notes. OK. Questions? Yes? Not in my daughter, because... but I got all the stickers. My son was learning the guitar, and I made all these little stickers and stuck them on his little guitar, because my wife didn't want me to put them on her guitar. But he was only 3. So it was maybe stretching a little bit. Maybe it was 4 or 5. But I play with this sometimes myself on the piano, because otherwise, it would have been a huge waste of time. And it feels nice, but I haven't put stickers all over the piano either. So what I really want is a set of lights that shine down onto the piano, so you don't have to desecrate the instrument, and that can shine through your fingers as well. It's problematic. Yes.
Isn't the idea that if you play similar sounding,
yeah.
similar colored notes,
yes.
they're going to sound good together?
Yes, exactly. So I feel like that'll give people a nice way to explore instruments interactively rather than which is what Python is all about. Right. Now, so here's Mr. Schumann, and he's gradually coming back to the same kind of key he was in at the beginning. Can you see that similarity in color? Although he's gone through a purple phase. He's feeling a bit... OK. And then let's look at Bach, the guy who started this all with his computer programs. And you can see his music's a lot more chromatic. There's a lot more variation in the colors. So even looking at a piece of music, this gives you a lot more of a feel for what it's like. The other thing is that in normal notation here. Whenever you get an accidental, which is when you're saying, well, normally in the key we're playing in, you wouldn't play an A. If you see an A written there, you play an A sharp. But then you get these funny little things like this, which says, oh no, play an A natural now and make that an F sharp. And it complicates everything when you're reading music because you've got to concentrate on two different dimensions at once. So the colors here actually tell you that information without you having to take that in, which is quite nice. Okay. And I also have a Chopin nocturne somewhere, but I don't know where that is. Okay, so those are those things. And so now time to look at some Python code. Okay, but any other questions in the meantime? Yes?
Have you thought about combining this with the stack library for Python?
The stack library?
Yes.
I did think about it briefly, but then I realized that I didn't know what the stack library was. And that was only after you asked me the question. Generating sounds, yes. Awesome. So I didn't know about that particular library. I had another experiment which was to use this for analyzing sounds so that when you listen to a piece of music, you get a visualization of all the colors. But it turns out that I'm not really good at solving the intractable problem of how to detect different frequencies that are being played simultaneously on different instruments. So I gave up on that.
That's exactly why I asked that question.
Yes. Okay, well, so I want to hear about that. So, but generating sounds would be fun as well. So that sounds great. Yeah. Question, yes. Yeah.
Are you representing the same color for your octaves and things like that?
Yes.
Going out to yellows, all A's.
Absolutely. So that's where I skipped over this very, very hastily. But let me go back to this because it will help. So basically we're saying this is the distance function I'm looking at. Notes that are the same notes should not be seen as difference between each other. So the distance between them is 0. Notes exactly the same, like a note, but an octave apart, we want to see the same as well. So the difference between A and 2A is 0. And then you want it to be independent of direction so that the distance between two intervals, it doesn't matter whether you look at the lower note and the higher note or the higher note and the lower note. And then also the same interval, if you move it further up or down the frequency spectrum, you want to have the same distance. That was a general idea. So, yep.
So, as a sort of an extension of your project, would be quite interesting to map a note to a color and then use the scale to do hues on that color. And then swap that into a Raspberry Pi with some lights and actually just play your music with lights.
Yeah. Yeah, so this could form a kind of music visualization for deaf people, where you could actually appreciate some of the. So do you know about this? What's it called? Rimsky-Korsakov had this thing, synesthesia, where like some people actually like they sense things with other senses when one sensor signal gets loaded in their brain. So like he always thought when he was a little child and his parents took him to musical concerts that they dimmed the lights so that you could see the colors, because when music was played he would see these like light color things floating around. So so you could actually generate that kind of experience and maybe give people more exposure. Yeah, that's a great idea. And also Raspberry Pis are cool. So wait, I was going to show you. So LibreOffice is not slow. It's just thoughtful. Yeah. It's nearly there. Any other questions? So Gustav, you wanted to say something, but you can't actually breathe. You're going to say the same thing. Yes. Excellent question. Yes. So these are the things that I didn't show you from my little HTML things because they don't work at the moment. But you can draw chords, and there's this correspondence in the little angle things, as well as in the wait, so let me just get this up so you can see. 640 by 480 is wonderful. Okay, so like you've got these angly things going, and if you have like wait, there's actually a different 2 times 3 is 6. That's the best maths we've done so far. Okay. So this is supposed to have, no, previous one, sorry everybody. Real. You see, these are meant to have, no, I don't have it here, but there's this geometric combination of like, if you've got a major third and then a minor third, then you get exactly the same pattern going and similar relations between the colors. So that's part of the idea. And then also, if you like playing something like a guitar where you're choosing notes that goes a chord together, they'll have that same correspondence, even though somebody who invented the guitar decided that there should be one string that has a different interval to all the other strings. So yeah, that's it. Okay, any further questions, or shall I dive into some code? Code. Okay, now this code was designed as Pep 8 instructs to not ever wrap when you show it on a 640 by 480 screen. So any wrapping that you see is musical. Okay. So this is just for interest's sake, because I don't feel like this is the most interesting thing that has ever been done. Okay, so what I have, I've got my little make file, and then I decided, because the right way to obviously do any kind of exploration of maths and color is to use an HTML templating language. So I decided, because I hadn't yet discovered Sphinx, that I would write this all in Genshi templates and then embed little bits of code in them. So here's an example of one thing. So this has got a little bit of embedded lily pond, and then it's also got, for these images, right, I want a source for this image, so call this function and then return it in the image, and then, does that make sense? So then those little functions are defined in here, and so basically I've got, now you can see this is the bit of code which really works well at the moment. So when I was exploring the different kinds of functions mapping the tones onto colors, then I would pass in a different hues function here for the different pictures in the thing as I'm exploring it. Does that make sense? And then there was also a thing, and then there's all kinds of color conversion things which are boring, which you have to deal with. So for that, I'm using, at first I was using grapefruit. My later version, which I committed changes to, and then which doesn't build anymore, which I discovered just about 2 hours ago, uses another thing called color math, which is broader. And then there's matplotlib doing all these plotty things, which is great. And then right at the bottom here, I think if I run this, I can give one of the functions and get it to show me the image that I want to see. So for example, you see, this is what locals was intended for. Okay, so I can call any callable in here, and this is obviously something that I would happily distribute on the public internet so that somebody can find a way to destroy my computer with it. Okay, so draw torus chord. See, this is a nice function which doesn't work at the moment, so let me demonstrate that failing. And then write a test case. Yeah, I'm ashamed to admit it, but I have no unit tests for this entire system. Okay, so here we go with a command prompt. Now, the truth is that this is not my natural area of expertise, so everybody who runs IPython and everything is going to be breathing deeply inside as they watch me do this silly thing. So I'm going to run and tell it draw torus chord. Is that what I'm going to say? No, but chord's not actually spelled like that, is it? No. Ah, terrible. Can't do that one. So let's find another one. Oh, this one's got default arguments. That'll work better. I have not tested this. Oh, look. Okay, do you all understand? That makes lots of sense, right? You can see how it works.
Or not works.
No, it worked perfectly. It just used a non-GUI backend. It's told me that it's drawn the picture in a non-graphical way. I'm not going to try and fix that live. I didn't try this before, and this was a foolish experiment. I repent. Okay, so we've got, and then the other thing which is interesting, maybe slightly, is this thing about how do you work out when you've got this color space and you want to find distances along it. How do you get a whole range of different colors and then work out distances and find the ones that you want? So for that, I used NumPy to give me a nice spread along these spaces. This works quite nicely because NumPy is designed for doing multi-dimensional things, and what I've got is all these little three-dimensional spaces that relate to each other. So I can give it a whole bunch of stuff and say, give me a nice spread of things, and then fiddle with them. That's the best way to describe it. Everything else is totally explained by that code there. Okay, so So the point I'm trying to make here, and then when I want to convert it to a color, then I take the things that I've got from NumPy and go, now make those into grapefruit colors, which I can then translate into RGB or whatever that I need to actually display them. Okay, so the point of this is not really that this code is anything inspirational, but it's that actually Python is a great thing if you're wanting to like fiddle around and mess around with things, because you can like make these little scripts with it, and you could do this with other languages as well, but I found it quite useful. Maybe it's because I usually program in Python. Okay, any further questions? Okay, that is mostly what I actually have to present to you. So I think we're done. So that means we can get to lunch before the other people.
Yes, 15 minutes. We start the first line.
Okay, awesome. Cool. Thanks, everyone.